Good morning, dear friends. In the last session, we have seen one problem related to Kirchhoff Voltage Law. Today also, we are going to learn the next problem, how one can do how can implement the Kirchhoff Voltage Law. In this case, in this today's lecture, I will choose here the current direction as I1 is clockwise direction, I2 is in the anti-clockwise direction. In the next lecture, the same problem, I will choose I1, I2 are both are in the clockwise direction. So how we can use the Cramer's rule and how all the derivations I will explain with the final answers. So now we are going to write the as per the Cramer's rule. We are going to write this equation here. First one is the already we know voltage matrix is equal to resistance matrix into the current matrix. This is we already in the last 3 more lectures we are writing this. So now this voltage matrix, in this voltage matrix here the current is moving up. Similarly here also current is moving up. Both the cases voltage rise, that means minus plus. Both the cases voltage rise. Therefore I can write 9 plus 90 and 125 both the voltage. That is equal to resistance. Resistance is first to R. We will get 2 cross 2 matrix. So 2 cross 2 matrix, first R11 matrix is nothing but sum of the resistance in the first loop. So 25 plus 10, that is 35. Then second loop, here R12 is nothing but common resistance between first loop and second loop. In the common loop, common resistance is 25. Both the current I1, I2 are the same direction. So we can write this also positive 25. Then similarly R21, that is also same value 25, since both the resistance between the two loop. Then next one will be the final 2 cross 2 R22. R22 is nothing but sum of the loops, sum of the resistance in the second loop. So 25 plus 5, that is equal to 30. Then current we can write it as I1 and I2. Write it as I1 and I2. Now this equation is also divisible by 5. This entire equation also divisible by 5. So entire term I am dividing by 5 in the both rows. So finally we will end up with the values 90 divided by 5, that is equal to 18, and 125 divided by 5, 25, is equal to 36. 5 divided by 5, 7, 25 divided by 5, 5, 25 divided by 5, 5, 30 divided by 5, 6 into I1, I2. I hope you understand. 7, 5, 5, 6, I1, I2. Then we can write it as delta is nothing but 7, 5, 5, 6. So 42 minus 25, we will get 17. Similarly, delta 1 is nothing but remove the first column with this voltage, replace the first column with the voltage matrix. Therefore 18, 25. The second column as such 5, 6. So we will get it the determinant. Delta 1 is nothing but 108 minus 125, that is equal to minus 17, right? Then delta 2 is nothing but removing the second column, replacing the second column with the voltage matrix. First column is 7 and 5. Therefore 7, 5. Voltage matrix is 18 and 25. When we do this multiplication, we will get this value as 175. That means 7 into 25 minus 18 into 5. 175 minus 90, that is equal to 85. Okay. Now From this we are going to find out I1. I1 is equal to delta 1 by delta. So the delta 1 is, we know, minus 17 divided by 17, that is equal to minus 1 amps. Then I2 is nothing but delta 2 by delta. So delta 2 is 85 divided by 17, that is equal to 5 amps. 85 divided by 17 is 5 amps. So now we are going to find out what is the voltage across this 10 ohm, 5 ohm, 25 ohm, etc. So that we are going to ensuring whether it will follow the Kirchhoff voltage law. So now let me take this first resistance 10 ohm. So voltage across 10 ohm is nothing but current flowing through the 10 ohm is I1. So I1 into 10. So I1 is equal to, already we know, minus 1 into 10, that is equal to minus 10 volt. Then voltage across 25 ohm. So this voltage across 25 ohm, both the currents are down. So that is I1 plus I2 into 25. That is equal to, I1 is minus 1 amps, I2 is nothing but 5 into 25, that is equal to 4 into 25, that is 100 volt. Okay. Then voltage across the resistance 5 ohm. Voltage across resistance 5 ohm is nothing but current which is flowing through the 5 ohm is I2. Therefore, I2 into 5. I2 already know 5 into 5, that is 25 volt. Let me draw again the entire circuit here with the detailed explanation based on the calculation. So here we have 90 volt and we have 125 volt. Then this is 10 ohm, then 25 ohm, then we have 5 ohm. Okay. So now we know I1 current is clockwise direction. We assume that I1 current is clockwise direction. But what we get, I1 is minus 1 amps. That means I1 direction is different. That is, this is the I1. I1 is equal to 1 amps. Okay. Then I2 is equal to same direction. This is I2 is equal to 5 ohms. So we can write this is I2 is 5 ohms. 5 amps. Sorry. I2 is equal to 5 ohms. Then voltage across this 10 ohm, already we have calculated minus 10 volt. So we can write here this voltage is minus positive 10 volt. Then voltage across this resistance is nothing but 25. Voltage across 25 ohm is 100 volt. Here positive, negative. So 90 volt is nothing but minus 10 volt plus 100 volt. So 100 minus 10, we are getting 90 volt, right? Then what's the voltage across 5 ohm? Voltage across 5 ohm is 25. So we can write it, this is 25 volt. So now we can say this is voltage across 25 ohm, already 100 volt. Then we have additional plus 25 volt plus 25 volt. So 100 plus 25 volt is nothing but 125 volt. Otherwise 125 volt is equal to sum of 25 volt plus 100 volt. From this we proved this Kirchhoff voltage law. When for this calculation purpose, for your better understanding, after drawing the circuit, assume any conversion method of I1 and I2, solve it everything, then later draw the circuit once again and note down based on the calculation how I1, I2 and the voltage across each resistance. Accordingly, you can verify whether that Kirchhoff voltage law, whatever implemented in this problem, is correct or not. I hope you understood the concept well, how one can implement the Kirchhoff voltage law. Those who have not subscribed this channel, kindly subscribe and like and share. Also press the bell button so that forthcoming videos you can see easily. Wish you all the best.